What is transfer orbit? We have Earth here, and there's a satellite in an orbit. If the satellite needs to go to a high orbit, that's here, so we need to transfer the orbit of the satellite. So we need to transfer the satellite to this orbit. So when do we do it? So for instance, if we want to launch a GEO satellite, which is a geostationary satellite, that is at an altitude of 36,000 kilometer. 36,000 kilometer. So to launch the GEO satellites, what we do is we launch a satellite as an LEO, which is the low Earth orbit satellite. So low Earth orbit satellites, that would be something like 400 kilometer altitude. So we launch the satellite to a low orbit, and then we do a transfer to the GEO orbit. So it's quite a big distance. So that's one of the reasons we do transfer. And there's another reason why we do transfer is when we have the LEO satellites that's in the low orbit, what happens is that after a while, after 10 years, 20 years down the line, it comes to a low orbit. Why? Because of this atmospheric drag that is is going to delay, or it's going to affect the energy of the satellite, and it's going to slow it down. So that means it will fall back to a low orbit. So what we need to do is we need to transfer the satellite back to its original orbit. So one is during the launch where we discuss that we have an LEO and then we transfer it to a geo satellite, or if due to, we say, orbital decay. Orbital decay happens because of orbital decay, and this happens due to atmospheric drag, and that's one of the reasons that the geo satellite is much above the atmosphere. And also uh, when we look at LEO satellite, that we have got International Space Station and Hubble telescope, that they are two LEOs, but the Hubble telescope is at an altitude of 600 kilometer. That is just above the atmosphere, because we want to see a clear picture of the universe, the galaxies and the planets. So that's one of the reasons that's just bit above the atmosphere. But International Space Station is vulnerable for atmospheric drag, so it can come to a low orbit, but we need to keep on giving some boost to get it to the higher orbit. So how do we achieve this? How do we transfer the orbits? How do we transfer a satellite from low orbit to a high orbit? So what we have here is, this is Earth, and this is the low orbit, and we have a satellite here. And what we want to achieve is to get this satellite from this orbit to this orbit. So this is called the transfer orbit. So what we do is, before we get it to the high orbit, we use a transfer orbit, which is an elliptical one, and to get the satellite from here to here, and then we get it to this high orbit. So what do we do to get it to the high orbit? So if you think about a satellite, the satellite is orbiting the Earth because of the gravitational force that is applied by Earth. So Earth is attracting the satellite, and that's how we are having a circular motion here. So if we want to get it to another place with a higher energy, because the total energy is high here, the potential energy is bigger than here. So we need to provide some energy to get a satellite from here to here. So what do? Is we give a boost. How do we give a boost? Boost of energy. That means we need to increase the velocity of that satellite. So just like any other rockets, if you want to give a boost to forward direction, what we do, we have to fire a rocket backward. So if we fire a rocket backward, the satellite will move forward with a greater velocity, and that's what we do. So that boost, the the energy boost that we give here, it's called prograde prograde burn, or we can also say it's a posigrade posigrade burn. That's basically an abbreviation for a positive grade burn. Why? We need to boost this satellite in this direction, and to do that, what we do is that we fire the rocket this way. So if we fire the rocket this way, we give a boost this way. So the satellite will start to move in this direction at a high velocity. So what will happen is that the satellite will move with a high velocity, and during this path, the kinetic energy is converted into potential energy, and by the time the satellite comes here, it won't have much kinetic energy, but it will have high potential energy. That means even the velocity is reduced compared to this one. And after the satellite comes to this place, we give another boost. How do we give another boost? We fire another rocket this way, backward, so that it will have a more thrust in this direction. So always understand the thrust and the rocket fire, are in the opposite directions. You fire the rocket backward, and the thrust will be applied this way. So you're familiar with the rockets. When we fire rockets, we fire the rocket this way, and the rocket will move this way. So there's more thrust here. When there's more fire, more rockets fired this way. So if you want to provide a thrust this way, this way, we fire the rocket this way. So I'm going to put the thrust in red and the rocket fire in. So here we are firing the rocket. So we fire the rocket this way, so there will be thrust this way. So now we have got the satellite in a higher orbit. So in terms of the velocity of the satellite, as you know that at low orbits, the satellites have their velocity is higher than the velocity here. So say for instance, if we say the velocity of the satellite V1 here and V2 here, V2 is less than V1. Do you know why? Because we have an equation that V is equal to gm over r, and V is the orbital velocity we are talking about, and the velocity is become smaller when the radius is greater. So what's happening? So when we give a boost by firing the rocket this way, so the velocity increases here. So if the velocity here is V3, V3 is bigger than V1. So V3 is bigger than V1, but V2 is less than V1. So what's happening to the velocity? So the V1 is increased by the boost, which is a prograde burn, and V3 is bigger. And then V3, the velocity is getting smaller and smaller, and when it reaches this point, and that's another thing, this point is called apogee, apogee, and this point is called perigee. So perigee is a point that is closer to the Earth. If Earth is the one focus in the ellipse, perigee is closer to the focus where the Earth is, and apogee is far away from Earth. So at perigee, we give a prograde burn, and because of that, the velocity is increased. But by the time the satellite comes to apogee, the velocity is reduced to a point that we need another boost. But even after providing the boost, we now got a velocity v2 which is less than v1. So we should be aware how the velocities change from the low orbit to high orbit. The velocity get increased because of the prograde burn, but it decreased once it reaches the apogee point because it's a very, like if we talk about this one, if it's a GEO satellite, we're talking about 36,000 kilometers. So if this is 400 kilometer, and that point is 36,000 kilometer. So when the satellite moves from here to here, it's traveling to very large distance. So in that distance, the velocity is reduced. And now let's talk about the kinetic energy. I mean, that's another thing that's important to know. The kinetic energy here and here, because velocity is higher here compared to a point here, the kinetic energy is less here compared to this one. But the potential energy is increasing when the satellite is going to a high orbit. So let me take the potential energy here as U1 and kinetic energy as K1, and here U2 and K2. So what do we know about the potential energy? So U2 is greater than U1, but K2 is less than K1. But let's take another point somewhere here. So here we have, say, U3 and K3. So how do we compare U3, K3 and U1, K1? The kinetic energy here, K3, is greater than K1. Why? Because we have given a prograde or posigrade burn that has supplied more energy to the satellite, and because of that, at point in the elliptical path, we see that the kinetic energy is greater than the kinetic energy the satellite had when it was in the low orbit. So let's quickly summarize that the whole things that we discussed so far. So this is basically the summary of what we have learned so far. This is Earth, and we have a satellite in low orbit, and we want to take it to a high orbit. And what we do is that we fire a rocket this way. So that means we are giving a burst in this way. So we call it a prograde burn, which will give we even call it like delta V. That means we are adding the velocity and adding the kinetic energy of this satellite so that it'll go in a elliptical path and reaches this place, and we give another prograde burn, and then it'll stay in the higher orbit. And the next thing we looked at is the velocity and the kinetic energy, potential energy at each point here. In high orbits, the velocity is less than the low orbits, which we can use the formula v is equal to square root of gm over r. So the velocity, the orbital velocity, is less than the velocity in low orbit. So let's write that down. So vd is less than va. So we have a point here, A, and we have point D here. So VD is less than VA. And VB, we are giving a prograde burn that's increasing the velocity of the satellite. So VB is greater than VA. So is greater than VA because of this the prograde burn that we give the satellite that's increasing it. And how about the kinetic and potential energy? So the kinetic energy here is increased by this prograde burn. So we know that KB is greater than Ka. KB is greater than Ka. And how about when the satellites move to a high orbit, the kinetic energy of this one is less than the, the kinetic energy of the satellite in low orbit. Because do you know why? Because we know the velocity is lower. So therefore, the kinetic energy here is less than the kinetic energy here. So we can say that KD is less than Ka. And how about the total energy? Okay, before the total energy, let's think about the potential energy. The potential energy increases when satellite moves to high orbit. So that means UD is greater than UA. So we can write down here UD is greater than UA. So I think it's important to understand the way how the energy and the velocity changes because it may be a bit confusing because someone might ask, well, you are adding a boost, a prograde burn, and increasing the velocity, and how come the velocity here at a high orbit is less than the velocities here? Do you know why? Because we are increasing the velocity of this satellite, but what's happening is that the velocity is providing the kinetic energy for the satellite to move a high orbit, and while moving the high orbit, that kinetic energy is converted into potential energy. So the total energy is increasing, but what is increasing is the potential energy, but the kinetic energy is being reduced. So that means the velocity at high orbit is less than the velocity at low orbit. So this is to move a satellite from low orbit to high orbit. And how do we bring a satellite from high orbit to low orbit? It's exactly the same principle. So in this case, we have to take the satellite to a low orbit. So instead of giving a prograde burn, we give a retrograde burn. So the burn should be in this direction. That will slow down the satellite and that will move the satellite in an elliptic a circle, but is smaller than this one, and that will ends up in a second retrograde burn. It ends up in a smaller circle. So that's called retrograde burn. So retrograde burn is to slow down the satellite and bring it to a low orbit. So if we are having a satellite at a high orbit and we want to bring it to a low orbit, we use a retrograde burn. So this is the actual difference between prograde, or we say posigrade, and retrograde burns. Posigrade or prograde burns are used to get a satellite from low orbit to high orbit, and the retrograde burn is used to get a satellite from high orbit to low orbit. And in this situation, we have to provide a forward thrust that is in the direction of the motion. That means that we have to fire the rockets backward. So a forward burn or prograde burn, we fire the rockets backward so that we are adding the thrust this direction. And for retrograde, we have to slow down the rocket so that it can go into a smaller orbit. That means that we have to apply backward thrust by firing a forward rockets. So we need to be careful in the terminology because for the backward thrust, we apply a rocket forward, which is in the direction of the orbit so that it will slow down the velocity and it goes into a low orbit.